If you're looking to get an introduction for Spring Pulsar, you're in the right room. My name is Chris Bono. I'm a software engineer on the Spring team at VMware. And today, it's going to be a pretty quick slide deck. What we're going to do, the two goals of today is to give you a high-level overview of what Spring for Apache Pulsar is, and then spend the rest of the time showing you how to use it. The use case we'll do a demo. We're going to go through and do a demo. The use case is going to be very basic. We're going to produce some data and consume some data. The point of it being is we have very little time, and it's just to show the features on the periphery that if you use Spring for Apache Pulsar, you can see some of the features that you get that come for free. And so one of the assumptions we make today is that everybody here knows what Pulsar is. And so the other piece of the equation is that everybody knows what Spring or Spring Boot is. And so if you're not familiar with Spring, it's a JVM-based application that handles a lot of the plumbing type of work for you so you can focus on business logic. It's the kind of at a high level. Spring Boot extends that such that it has an opinionated view on configuration and on dependencies. So the idea being that you can just get up and running with an application that you can put in production that'll just run with minimal fuss. And so if we take Apache Pulsar and Spring, how do they fit together? Spring for Apache Pulsar is a library that lets you write production-grade Spring-based applications using Apache Pulsar that just run. If you're also familiar with Spring, this is not our first foray into messaging. We also have support for Kafka, AMQP, and JMS, and that's been there for a while. And we really had a gap when it came to Pulsar. And so about a year ago, me and one of my coworkers, we started the Spring for Apache Pulsar project. And this will, we think it's a good thing. So let's go over a little, the component diagram here. Let me see if I can see that. Really, the box it's an oversimplified version of Pulsar. Just imagine that box is all of things called all of Pulsar. On the left-hand side, we see the imperative client and a reactive client. And so I'm not sure if y'all know or have heard, but Apache Pulsar actually has a reactive client that's out. It's in release 0.4.0, and that's what we use on Spring Pulsar for the reactive side of things. And here, the imperative client is just the typical Java client. And so what we do is we auto-configure that regular client and the reactive client using Spring Boot. So if you configure your environment to say Spring Pulsar client server URL and point it to a particular URL, and then set up other properties on it, when you go to write your app, you can just inject that instance of the Pulsar client and just start using it. The other things we auto-configure is a Pulsar listener. And so what a Pulsar listener is it lets you annotate any one of your methods. And then with the Pulsar listener, you can consume data. And if you're familiar with Spring Kafka or any of the other Spring AMQP, it's the Spring messaging template pattern. So there's a XYZ listener and there's an XYZ template. And so this is the Pulsar template and the Pulsar listener. And Pulsar template's really just a wrapper around Pulsar client. And it provides some convenience functions currently, but the idea is that later on it'll also have improved transaction support and other things. There's also the reactive counterpart. So like we have a Pulsar listener and a Pulsar template, we also have a reactive Pulsar listener and a reactive Pulsar template. In addition to that, we also have support for Spring, for Pulsar IO and Pulsar functions. And so what that looks like is if you provide a bean that's of type Pulsar sync, Pulsar function, or Pulsar source, it'll go ahead and register that at runtime with the Pulsar functions runtime. We also have a Spring Cloud Stream Pulsar binder. And so these two, if you look at Pulsar IO and Pulsar functions and compare it to Spring Cloud Stream, they're very similar in that they both have source, processors, and sinks. One of the key differences is that with Pulsar's IO and functions, they run actually on the server, whereas with Spring Cloud Stream, it runs in a separate application. We're going to demo the Spring Cloud Stream Pulsar binder in our app today. Another thing is that if you can take a Spring Pulsar application and compile it with the GraalVM into a native image and to make it faster and smaller. We'll also demo that today. Another piece that you get is built-in observability via the Micrometer Observations API. And so by adding in a few dependencies and setting up a little bit of configuration, you run your app, and then you have traces and metrics. Automatic schema and topic detection is just something that we've added where you can, if you have, say, a topic or you have a type of user object, you can configure it so that the user object by default always goes to a specific topic and always has a particular type of schema set up for it. And so why would you want to use Spring for Apache Pulsar? Like, why do you care? The main thing is, we think, is increased developer velocity and developer experience. Just like whenever you use Spring Boot, you get a lot of the reasons using it is there's a consistency, there's a huge community behind it. A lot of the configuration and stuff is done for you. And now we'll demo that and see if we can see any developer velocity or experience with that.
Come over here to start.spring.io. And so start.spring.io is our Spring initializer. It lets you to bootstrap applications quickly. And so let's say we're going to take Groovy Java Spring Boot 3.2.0, and we're going to call this Acme Pulsar jar packaging Java 17, and let's see, add dependencies. Let's do Pulsar. You can see we have Reactive offering, regular Pulsar, and then this is the Spring Cloud Stream support. For now, let's grab the base Pulsar. I'm going to grab a few other things here as well, though. And so we can get Docker Compose support. Let's go back and add test container support. Let's go back and add tracing let's do distributed tracing, Zipkin, and distributed tracing. Okay. So at this point, we've got quite a few things in our application. Let's go ahead and generate. This is going to drop a file out on, let's do this, iterm. And so let's go to cd desktop Pulsar live stream. Let's unzip downloads Pulsar. Pulsar. Oh, I know what I did. Let me just do this real quick. Move downloads. Pulsar zip to here. And then, okay. Okay, unzip Pulsar to, there we go. Okay, to -d here. Okay, so that should have unzipped the file. Let's go into Pulsar, and then let's open up IntelliJ right now. Okay. Let me see what this thing's going to look like on the editor. Okay, cool. Make sure everybody can see the size of this. It's gonna. I'll make the text bigger. The menuing system doesn't really get too much bigger. Okay, so let's first. Okay, that didn't look like what I wanted here. Let me close this out. Where are we at? Okay. I did. Wait. Okay, see Pulsar. I did up. Okay, cool. Yeah, I had another. What happened here? Okay. That's funny. Okay. There we go. Okay, it was loading. Okay. So one thing let's look at. So this was the output from start.spring.io. And so a couple things you'll see here is the build.gradle that it spit out. Make sure everybody can see this. Yep. And so you can tell there is here's the main piece is this is the only true dependency that we need is Spring Starter Pulsar. This Brave actuators, Zipkin stuff. This right here is around tracing. This around here is for Docker Compose support, and this is some of the test container support. I didn't want to go back and forth into start.spring IO as we layered these in piece by piece. Just the jumping around would be problematic, so I went ahead and pulled them in all at once. Okay, cool. So now this is here. What do we want to do with this? Let's come back over here. Let's dig around a bit first. So compose.yaml, you'll notice that pretty interesting is that Spring Boot now has support for Docker Compose. And so any dependency that you add that buys into the Docker Compose feature, for instance, Zipkin does, and for instance, Pulsar does, you'll have an automatic Docker Compose file generated with the section of that technology in there. So here we have a built-in ability to start up Pulsar as well as Zipkin. And also for the test container piece of things, if you come down here to test, you'll notice that we have a little integration test that's created for us, and a test container, Pulsar container was generated, likewise for a Zipkin, which is pretty nice. And another interesting piece is here, this @service connection. This is newly introduced in Spring Boot 3 as well. It lets you take, okay, I have a container which has some dynamic ports. How am I going to map those into my auto configuration properties that I need? Spring Pulsar service URL. How do those mesh up? And so this magic right here does that for us. Cool. And so let's come over here. I'm going to rename the generated YAML file to properties file to YAML because we will be entering some things in here today. Let's see what else to talk about. So we looked at the compose file, we showed test containers. Let's go ahead and let me look at something real quick. Let me make sure I'm on Java 17 here, not GraalVM. Okay, so let's start doing something here. Let's create an app that's going to be something to do with users. We'll register users into a system, and our system will just be simply a topic that takes inputs and outputs. Okay, so let's come up with a public record user that has a string UID and a string email. That's it. And I also know that I want to use Faker for some dependencies. Let me actually come back to here and add in this Faker dependency. Faker is a library that lets you fake some data so that we don't have to worry about crawling across the internet to get some random users. And this will be a random user generator, if you will. Okay, so I've added that dependency. Now what we'll want to do is come back over here. Let's go ahead and create a user service to generate said users. Okay. I have some preloaded live templates here that will plop this out for us. Oh, I know what I forgot. I forgot to make a pop Gradle, so there we go. Didn't get my dependency. There we go. Okay, so all this does is you can ignore this runtime hints. This is a GraalVM thing that we'll cover later. Simple. We're just going to create a new user, and we're going to use Faker to give our UID and our email address. There we go. And now we have a user service. Let's do something with the user and user service. I'm going to go ahead and inject in private Pulsar template of a user Pulsar template. Now you'll notice I'm using field injection. This is somewhat of an anti-pattern. Don't do it. I'm able to do this because it's a demo. It works quickly. But don't try this at home. Okay, so there's a user service. And then now let's have a method called source users into Pulsar topic. And what we'll want to do, let's go ahead and use scheduling. So we'll schedule this initial delay 1 second, and then a fixed delay of another second. All right. Let's go ahead and enable scheduling. Boom. Now, okay, so what do we want to do? We want to say var user equals new equals user service dot single user. There we go. And then now let's say Pulsar template. Here's the send method right here. So user topic user. That's it. And then let's go add this to the exception. I'm going to add a convenience function here that's going to help us differentiate log statements by color. Okay, so another anti-pattern sysout. I can do it because it's a demo. Don't try it at home. 1, 2, 3, and let's do produce. And then the color, let's do what? Blue, okay. And then plus user, that's it. Okay, so this alone, every 1 second will drop a message onto the topic, random user. Okay, so that's all fine and dandy. Let's go ahead and listen. Let's go ahead and consume this. Let's use a Pulsar listener. Topics equals user topic. Schema type equals JSON. Subscription name, subscription type. I could enter all this in, but I don't need to. The subscription type by default is exclusive. The subscription name is generated. JSON can be figured out by that automatic schema detection topics business that I talked about earlier. And then so, there we go. Let's do void log users from Pulsar topic, okay? And it's gonna come in, it's gonna be a user. Okay, great. And then let's do another system out with color. 1, 2, 3, consume. And then it would be, let's do ANSI color green. Sure. And then user. Okay, great. So at this point, I want to do one more thing here. I know that I want to show you some tracing, but I also know that I'm not using Spring Web, and Zipkin requires a web client on the class path if one's not there. And so what I'm going to do is observability Zipkin sender. I'm going to go ahead and add this Zipkin sender so that it will send the traces to the Zipkin server. Okay. So at this point, we've created an app that's going to produce and consume using tracing. And let's see. Okay, one more thing. Let's go into application YAML here. Let's do debug false. And let's do log level minimize. I'm going to turn down logging a bit. And let's do observability props. Save this for later. I'm going to make sure that we're sampling 100% of the calls just so that we don't have to wait around to get the traces. Okay, and so at this point, the theory is if I push the play button, this is going to start up. It's going to read the compose file. It's going to start up Zipkin. It's going to start up, it'll start up Zipkin. It'll start up Pulsar and then start producing and consuming. Let's go ahead and look at something real quick. When do I want to set? Okay. I'm also going to do something here. I'm going to go ahead and set Docker start only. So we're going to be starting and stopping the server multiple times. And what I want to do is I only want to start it up once and leave it running for the rest of our time together. Otherwise, it just takes more time to start up. While we're in here, let's go ahead and you can see that there's other Pulsar.consumer. You can see all the consumer properties we can set. You can see producer. This is from Spring Boot configuration properties. Let's just do things right in here like admin properties, functions. So we have all this ability to configure our application right in this YAML file. So next, let's go ahead and let's give it a run. Okay, boom. Okay, starting it up. You can see it's reading the compose file. It's going to take a little bit of time the very first time through. And so, do I have Docker running? Yes, I do. Okay. So what I'll come over here and do in the meantime, oh, this screen's kind of small. Let's do this another terminal. Let's do clear and let's Docker PS. And you can see they're up. Pulsar and Zipkin are up and running. Let's see. It's a little bit smaller. Okay. Okay. Yep. So now if we come back over here, not the wrong window. If we come back here, you can see produce, consume, produce, consume. So every second it's sending a message, receiving a message, sending a message, receiving a message. So likewise, if we were to venture over here. Let me go back to see what our ports are running on for Zipkin. It is 49551. And so now let's go over to a browser and let's go to localhost. Yep, there we go. That's all right. Cool. We have a bunch of traces here. You can see. Really, so let's just take any of them. This is the same pattern over and over. But if we drill in a bit, you'll see that there is okay. So it starts off here. The scheduling has a trace, and then it has a child span right here. And so this is the initial call down into that scheduled. This is the send, and then on the receiving side, here's the consume, right? Produce, consume. And so that's this whole call chain so far. Schedule, produce, and consume, and you can see the spans are here for us, which is nice. Okay. Now let's go back to, let's go ahead and stop this. And based on that property that we put, you can see that even though we stopped the server, it left the compose instances up and running, the containers up and running. Okay, so what do we want to do now? Let's add a little more functionality to this. So we have users coming into the system. Now let's introduce the concept of maybe registered users. So we would add some enum tier, right? We'll call it free, no money, basic, little money, enterprise, a lot of money. And then now let's also include a public record registered user that takes in a user and then a tier as well. Okay. Okay, that's great. Now, what do we want to do with this? So let's keep logging this the way we were. Let's think of this from a Pojo's perspective. Let's have this function that takes in a user and outputs a registered user. Okay. We'll call this register user. And we'll say return. Let me get this out of the way here. Return user. And we'll do something along the lines of, let's do var register user equals new registered user of user and null, all right, for now, and then return registered user. Okay, so one thing I want to do is another anti-pattern, var rand equals new random. This is not really very random, and it's not the proper way to do this, but it will give us some sense of a random index into this enum. So let's do rand.nextInt of tier.values.length. Okay, great. And then let's also print this out with color, and we'll do 1, 2, 3, and we'll say registered. What? Registered with, let's say, fancy color magenta plus RU. Okay. Also, I'm going to tab these over a bit so we can see what's consuming what, and then produce, consume, and then this would be, let's go over 2 with this. So one more piece. Let's also use Pulsar Reader. So we also have Pulsar Reader support, and we'll do that to look at the log registered users. And so what we'll have here is a registered user, and similar to above, we'll say with color, we'll say 1, 2, 3, reg user consume, and it'll be color, let's do yellow maybe, fancy color dot, okay, and then RU. Okay, so let's also scoot this over 1, 2. This will be after the register operation, so 3. This will just give us some indexing in. to the log, to the console. Okay, so this just doesn't work by itself. You know, if you're using Pulsar functions, you could use Pulsar functions to also bind this to the topics. We really need to say, where does this user come from and where does this register user go to? Which topics? How do we do that? And so we're going to use Spring Cloud Stream to show this. And so we'll come over here. Let's add the Spring Cloud Stream dependencies. Cloud Stream Pulsar dependencies. Boom. It is Spring Cloud Stream and Spring Cloud Stream binder Pulsar. There's one more piece that we have to add, and that is cloud. Typically, the way that typically the way that we would do this is just through start.spring IO. Again, I'm avoiding going back over there again. Okay, so we've added all the Spring Cloud Stream dependencies. Now the trick is going to be to come in here and do some properties to tell Spring Cloud Stream where to find the topics and what function methods to bind them to. So let's say Spring Cloud Stream, right? And let's do Spring Cloud Stream bindings. And so you can, what this does right here is this says, okay, can you see that? Register user. If we come back over here, you'll notice that register user is the name of the function, right? And so coming back here to our properties, wherever they went, there we go. So this is method name. Input means, you know, the input to the function of 0. Register user output, and likewise, this is the input and the output to the function. And so where does it come from? This comes from the user topic. And this just says, don't use Spring messaging encoding, use Pulsar schema encoding. Register user topic is where it's going to go to. Likewise with the Pulsar message encoding. One more thing we need to do is Spring Cloud Stream Pulsar bindings. And so this is a Pulsar binder specific setting. And we are currently working on getting rid of this so that we don't have to specify this, because you can look at the method signature and figure out that at position n0 it is of type user. You know, we can figure this stuff out, but for now we have this where it's an extra step you have to do. Okay. However, this little bit of coding configuration sets up all the things so that what we should see now is when we come over here, let's go through this again. We're going to source a regular user into the system. We're going to use Pulsar Listener to log that. At the same time, this register user function is going to pick up that new user and it's going to transform it into a registered user, drop it back out onto the registered user topic, and then of which we're going to use a Pulsar reader to read the register topic, the register user. Okay. And so real quick last thoughts. We got everything in there. I think we're good to go. Let's give it a try. Let's see what we get here. Oh yeah. Okay. So bad developer. Okay. Pulsar reader. Whoa, where? Pulsar reader of what? So this is actually a good time to say. Typically, I need to say topics, and I'd say reg user topic. I'm going to take this opportunity to also show a different feature though. So if I wanted to use some of those default binding things I was talking about, so Spring, let's do this, Spring Pulsar default type mappings, right? And so if I say type mappings of, what was it, user class, let me say, let me remember if I have a type of reg user class, string called dot mappings. It is topic info. Topic name is reg user topic. And then let me go what the type mappings look like. Let's go to default type mappings. Let's go to Pulsar mappings. Not quite what I'm looking for. Okay, so let's do this. So type mappings is, okay. It will be, oh, I know why. It is inside of Pulsar properties. Okay. There we go. I didn't remember exactly what the thing was. So, okay. So it's a class, message type, topic name, and schema info. Okay, message type to topic name. So let's go back over here. All right, it is a list of, and then this has message type, and let's do reg user class, right? Com Pulsar application registered user, and then this is topic name, right? And then schema info, we could also say schema type is this, schema message type. We don't need to because it infers JSON on its own. So what we're gonna do is leave this here. We're gonna go back over here and we're gonna leave our unspecified product there. And let's go ahead and try this run. All right. Topic name must be set on the reader builder. Oh, that's okay. Well, the topic, the automatic topics and resolution thing is not supported by the reader yet. I forgot. There's an issue, and it's okay. So now, anyways, but you know what we'll do? To prove this, we'll go and say user. And we'll say this goes to user topic, right? And so we'll come over here back to the Pulsar application and we'll trade this one for this one. Oop. We'll take it off the listener and still show it. Okay. Oh yeah. Okay. One more caveat with the reader. You need to tell the reader where to start from. Start message ID is earliest. Let's call latest, otherwise it's going to get a bunch of extra stuff we don't want. Okay, 4th time's the charm. Let's try it. Yay. Okay, cool. That's what we expect to see. And so if we deduce this a little bit, we'll have a produce and a consume. This is what we did before. Then now this is our function registering the user. And then here's our reader consuming it. And this is just going to continue add on over and over. So what we'll do is, one thing I want to point out though is let's look at the startup time here. And so without GraalVM, this thing started in 3.9 seconds. And so call it 4 seconds is the startup time. And that'll get a little bit faster as it warms up and whatnot, but we can do better. So let's go ahead and stop this. And what we'll do now is let's go ahead and run this through GraalVM and see what how much that improves performance. Let's do this. I know this one thing that is with the Docker Compose support, because the service @service connection is the magic that we've been using to not have to set any properties, right? And so that doesn't quite work with the Docker Compose support yet. And so what we need to do is say Spring, come down here to Pulsar. I need to tell it a few things. Spring Pulsar client service URL is Pulsar://. And then if I come over here, we can see that, where is this? Okay. TCP, this is Pulsar, and then, okay, this is the proper port for the Pulsar service. We'll do localhost, we'll do that, and then likewise admin service URL is HTTP localhost, and then 4953. And then likewise, the Zipkin stuff has a URL that it needs as well. Let's get rid of that. We already added that. And let's do localhost 49951. Okay. And so we'll be ready to, when we want to add GraalVM, the only thing that we need to do is come over here and GraalVM plugin. That's it. That one line is going to start using GraalVM. I also know that from a convenience based because of Java 17 and add opens, we want to add opens to GraalVM so that we don't see nasty messages when we start up. Okay, I'll pop Gradle. And then what I want to do at this point is just come over here to a terminal. I want to make sure I'm using this Java, the GraalVM. Now if I do Java-version, there we go. GraalVM 22.3.3, that's the minimum version I need to use, or 22.3. Okay, so let's do, go ahead and Gradle W, native compile. This is it. And so now, so the build time takes longer. It'll be quicker to start up, but it's going to be slower to build. It's a trade-off. This is typically the time whenever I go and say, okay, let's go talk about what's new and what's upcoming in Pulsar to kill some of this time. And so the things that we're going to work on next is transactions. And we want to have, whenever Pulsar itself has really strong support for transactions. And so we want to bring that into the Spring ecosystem so that whenever you use Spring transactions and, for instance, annotate your methods, business methods with @transaction, that if Pulsar is in that call chain, that it too can participate in the same JTA transaction. And another thing is auto cluster failover support. And so right now we just allow you to specify through configuration properties, you just specify your single service URL, but in real life, you'll typically have a cluster that has multiple service URLs for backup and whatnot. And so Pulsar has really good built-in support for URL providers where you can say, here's my primary, here's my secondaries. So we're going to extend that into our configuration properties. And there's actually a pull request out there right now for that. Other than that, though, really what we want to do is, up to this point, the project started out in one repo. It was the binder, the core, and the boot configuration. And since its inception, the core is still the core. The boot has moved out to Spring Boot 3.2. The binder is into Spring Cloud Stream 4.1, and they each live in their respective homes. And up until this point, we've came up with a set of features that we know are core and the ones that we think people will want. But really, at this point where we're at, we want people to tell us what do we want to build. Let's please get on the repo and star it and create some issues. Tell us what we're missing, how we can improve, and let's build something together. Okay, that's a lot. And we're still talking and we're still waiting on GraalVM. So that's it should be wrapping up real quick here. Yep. It's like watching a pot of boiling water. The trade-off though is really worth it. When we go back to, we had a startup time of right about 4 seconds, right? So you'll see something different here now. Okay, cool. We're done. It says native image written to this subdirectory. Let's run it. Native compile Pulsar. Okay, there we go. I'm not sure what I missed here. It was reflection utils. Not sure, but nonetheless, it's running. And so this is nice. So we went down from 4 seconds to, let me try to get this, to I'm not sure why it's doing that, 0.368 seconds, from 4 seconds to 0.36 seconds. And you can tell it does run faster. I can notice we've done some benchmarking. It's going to run faster as well. And so same thing, produce, consume, registered, the little call chain we had before. And yeah, that is it. Let's see. I think we've covered the basics here. There's a bunch of other features that we have in there. We have Tombstone support we've recently added. And so one thing we didn't cover today is the reactive support. And so it's the reactive support sits on top of the Pulsar client, the Reactive Pulsar client, which is an Apache open source project as well. And it's if you haven't checked out that repo, you should check that out as well. You don't have to use Spring Pulsar to use the Reactive client either. And so feel free to check it out one way or the other, with Spring Pulsar or without. It's some really good work.
That is everything I wanted to cover today. So let me go back to the slides in live demo. That was what we just talked about. What about GraalVM? We just talked about GraalVM. Here is some here's some other links and the QR code. If you scan it or you're interested, it has all the links in it. If you're interested in the project or you like the project, please star it. And also please check out the Pulsar client Reactive as well, the Reactive client behind it. It's actually an open source Apache project. It was Laurie Hotari here was one who actually contributed originally, and Christoph, is Christoph here? No. They did basically almost all of the reactive side of the Spring Pulsar work, which was great. Thank you.